Hi, hello guys. Good afternoon. Today we are going to see another video on introducing Aspire for selective prediction in LLMs. It is basically like calculating accuracy of the LLM which is predicting the text. Nowadays, LLM change the way how we interact with the computers. It is changed a lot. I think most of the audience who are watching this video will be already familiar with the LLMs or text generations or generative AI stuff, everything. Um, we know that LLMs are good at capable of generating a large number of texts what we desired or the questions what we ask. Still, the models are not well accurate, or it has some uncertainty because LLMs will be answering different types of answer to the same questions we ask to it. Like if we ask the same question to the LLM for the first time, it will give a response A, and the same question again at the same chat, we if we again ask that, it could respond as a the response B. The core aim of the text will be similar, but still there will be some changes in it. Spare is nothing but a new framework from Google. They have introduced this. Its main aim is to like calculating the accuracy of the output of the LLM, so which is being generated. At the end of the day, we are going to predict how accurate the answer is, how to calculate the average. We have another traditional technique, like each and every word which is being generated, right, will have an accuracy output. By taking the average of that output, could do the overall average, but I think that doesn't mean that much, because the text which is being predicted will be have an always have an high accuracy, but it need not to be in a uh, correct output. Okay, the this much time what we saw is a simple interaction of this aspire. Uh, let's see how we can achieve this technique, like whatever we ask a question to an LLM, right? It could generate answer with how much the answer is correct to the questions, or how much the answer is relevant to the questions with an output score. We could see how we can achieve that actually. Uh, okay, when it comes to giving us output with the accuracy score, right? We need a important technique named selective predictions, the where the user could set the risk level, and then if the response meets within the risk level, right? If the user sets the risk level should be a 50%, and if the risk score is within the 50%, then the model could give out the answer to the LLMs. Else, it would be like saying like, "Sorry, I couldn't respond to the questions what you have asked." Like that. This could be used in enterprise grade chatbots or LLMs, where we could set the risk level to the minimal, so that the answer which is generating will be uh, most relevant to the enterprise which is deploying that LLM. Uh, this will also give us a selection score, which could be used for the output is being selected to given as an output to the user, or it should not give it to an user. Before the selective prediction, right, there was a semantic uncertainty and several self-evaluation attempts, like the LLM could generate the answer, and the answer will be again passed to another LLM, which will be added with the prompt. Is the answer is correct or not, or is the answer is relevant to the question or not? Is the answer is true or false? Like that will be added with the prompt, and then passed to an LLM. It could give us an answer, but end of the day, it is going to not work in our use cases, because when it comes to Q&A, the answer may be the LLM may also hallucinate. The hallucination should be predicted by the LLM is not that much effective. Let's see how this is solved by an Aspire. Uh, Basically, this is what selective prediction means. Like, if there is no selective prediction, right? A person will be asking which vitamin assists the blood clotting. It would be like answering vitamin C. And the correct answer is actually vitamin K, not vitamin C. It will be passed with an LLM. This is without selective prediction. If the selective prediction comes into the picture, right, the answer will be the answer is vitamin C, but the score is 0 0.1. With this, the user could easily identify that the answer which came out of that LLM is a totally a false output. So that this Aspire framework, right? Maybe this could be integrated with any LLMs, so that at the end of the day, this could make a benchmarking system also in future. Let's see about the Aspire itself. Okay, Aspire means adoption with self-evaluation to improve selective prediction in LLMs. It is basically a selective prediction only, but it comes with the advanced features in that added up. Uh, this is was actually this framework was done by Google and presented in the findings of EM 2023. Uh, Aspire is nothing but it is a fine tuning LLM with the PIFT, like parameter effective fine tuning method to generate the confidence score with the output of the LLMs. Okay. Uh, let's see the mechanics of Aspire. The mechanics of Aspire is not only teaching how to answer, but also evaluating the answer and verifying the answer which is generated by the LLMs. It is nothing but looking a student looking back at textbook and verifying his own answer. This mechanics of Aspire contains like three major components like task specific tuning, answer sampling, and self-evaluation learning. These are the main major three tasks. Let's see one by one. Task specific tuning. Task specific tuning is nothing but uh, it is a fine tuning method. It is not a fine tuning method. It is a fine tuning process actually. Uh, Basically, our normal LLMs will be fine tuned on tasks like Q&A, summarization, etc., etc. But here we are focusing on another specific task around it, like the method you used for this fine tuning, right? That comes around like soft prompt tuning, and the LoRa technique are uh, used to fine tune this. I mean, any LLMs in Aspire. Uh, in this the soft prompt and LoRa is mainly used for a strong generalization with a small amount of target task data set. Basically, it says like very small amount of data is more than enough for generalization for getting and evaluating the models itself. Like other fine-tuning LLM parameters are freezed, and adaptable parameters are added to the fine-tuning technique. All the fine-tuning techniques are like basically freezing out all the parameters which is already in an LLM and adding out some an updatable weights to it so that it could be trained easily. And the loss function used is in this technique is cross entropy loss function, which is very helpful for effective fine tuning in this method. By doing this right, the selective prediction performance increases because it not only improves the prediction, and it also improves the accuracy and enhances the likelihood of the correct output sequence. Okay. After task specific tuning, let's move to answer sampling. Uh, Answer sampling is nothing but after fine tuning, Aspire uses the same LLM to generate different answers for each training questions and create a data set for self-evaluation learning. Self-evaluation learning is next step of this. Basically, answer sampling uses beam search to pick up the top relevant answers, uh, and also it grades itself actually. It basically answer sampling is something is used to prepare a data set for itself to the next process. Then comes the self-evaluation learning. Uh, Self-evaluation learning is something like Aspire freezes the knowledge of LLM, which doesn't allow to modify the prediction output of it, but Aspire adds a skill to decide if the outcome of the answer is to increase. I mean, outcome of the answer should be like giving output with the predicted text and the score of the output exactly. This happens more so that it uses the grade of that self-evaluated answers and used to learn by itself and increase the accuracy over the time. Basically, this evaluation process can be done using soft prompt. Prompt itself a huge separate topic which we could see in later periods. Basically, this happens. Which vitamins will be assist blood clotting is a user's question. It is passed with the soft prompt to the LLM. Then the LLM gives an answer. Then the answer is added to the same question soft prompt, and then the same LLM produces the answer. The answer is correct with 10% probability or 90% probability, or the probability of the answer produced by the same LLM can also be generated using this soft prompt technique or fine tuning technique. Basically, the results of this is actually like it is evaluated with POQA or Trivia QA dataset or a Squad dataset. The green color here shows the adapted opt 2.7 billion parameter model with the Aspire technique, which gives the evaluation accuracy gives more higher in two major datasets. That 30 billion parameter models fails I mean, most of the times here, so that the Aspire technique could be a huge come over for the LLMs in futures. Uh, in conclusion, Google says that it is not only just a framework to be here. It is a future of LLMs trustworthiness. Uh, by using this can be used in any enterprise grade or production grade software, so that the Aspire will be giving us some output. With that output, we could say that is this answer should be passed to the user or not, can be predicted from this. That's it for today. We have seen how LLMs can be evaluated in future or in very near future using Aspire, Google's product. Uh, most probably we will see what's soft prompt in next video or any other videos. Thank you so much.